When Kevlar is mentioned, we think about military equipment, such as this Mitch helmet used by the American Army in recent conflicts. When we talk about carbon fiber, the first thing that comes to mind is a bicycle frame. And why not vice versa? Moreover, they cost the same, the density, and thus the weight is comparable, the mechanical resistance as well, and both have the same type of structural form, one made of fibers, black ones for carbon, yellow for Kevlar. So what's the basis for choosing to use Kevlar rather than to use carbon? First, let's make clear, Kevlar is the commercial name of a polymer patented by DuPont in the 1970s, the same company that also patented nylon. And it's the progenitor of all aramid fibers. Let's use a graph to help. This is a graph showing force versus deformation in a static tensile test of steel. First, I'll draw for you the course of the tensile test for the carbon fiber alone. And now I'll show you the tensile test for the Kevlar fiber. First of all, we see the ultimate tensile strength is similar for both materials and is around 3,600 megapascal. What distinguishes the two is the dependent inclination of the plastic modulus, which is very high for the carbon fiber, being greater than 400 gigapascals, and more limited for the Kevlar fiber, 70 to 140 gigapascals. This makes us understand that carbon is the best combination of strength, stiffness, and weight. And this is the reason it is used more in structures where there's a need for stiffness. And the thing that makes us appreciate Kevlar is this. All of this area here that I'm shading in, this area that I have colored represents Kevlar's resilience, which is to say its capacity to store energy during deformation, and it is very significant. It is 2 or 3 times higher than that of carbon fiber. And it is so high because when Kevlar breaks down, it doesn't behave like a fragile material, even if you wouldn't think so, because it breaks down by shredding or splitting. And in this way, it's able to absorb an incredible quantity of energy during the process of deformation, comparable to that of steel, which, however, weighs 5 times as much. Above all, we remain in a linear domain without any permanent plastic deformation, something quite different from what happens with steel. In other words, both Kevlar and carbon will break when placed under forces of similar strength, but to break Kevlar requires much more energy than that needed to break carbon fiber. This explains why it's used to produce cables of very great strength and why it finds use in the sports and in the military spheres for absorbing significant vibrations or to absorb tremendous impacts. And look, I'm not talking about toughness. So long.